Hello everyone, welcome to the next session on Advanced ANSYS Workbench tutorials. In this session, we will analyze a 45-degree bend pipe for its steady-state thermal analysis. We will start by double-clicking on steady-state thermal module. We'll first go to engineering data and double-click. We will be using two materials for analysis. First, we'll click on engineering data sources, general materials. I will choose stainless steel as one of the material, so I'll bookmark here. Then again I'll click on engineering data sources. The second material which I'll be using is the CPVC. I'll give the value of isotropic thermal conductivity, which is 0.137 watt per meter degree Celsius or Kelvin, it doesn't matter. So I have chosen these two materials. Now I'll go to project and update project. Next, I'll go to geometry and right click. I will import the geometry directly. Then I'll go to model and double click. First, I'll go to geometry solid. I'll change the material to stainless steel. Then I'll go to mesh. I'll give the element size as 0.01 meter and generate. Next, I'll go to steady state thermal. I'll right click here and insert temperature at this inner portion. I'll select the three of them by pressing the control button. Then I'll click on apply. Inner temperature I'll give as say 45 degrees Celsius. Then I'll right click here and insert convection on the outer surfaces. Apply. I'll get the film coefficient as say 50 watt per meter square degree Celsius. Then I'll go to ambient temperature. I'll give this as 25 degrees Celsius. Next I'll go to solution and right click, insert thermal temperature. Again right click, insert thermal total heat flux. I'll go to solution and solve once again. Once the solution is obtained, you'll go to temperature. So now you can see here the inner temperature is red, which is 45 degrees Celsius, something that we have given. And outside is 44.827 degrees Celsius. On this space over here, you can see the temperature gradient. Now suppose if you want to see individually over here, you can right click on the solution, insert thermal temperature. Instead of selecting all bodies for geometry, you can select this face and apply, and then you can just solve again. If you click here, you can see the temperature. So on this face, you can see here, this is the gradient of temperature. You can go to edges and select no wireframe, contours and select smooth contours. So you can see the variation of color. You can zoom and see the variation. So once you have got this result, you can go to total heat flux for this body. You can see here the maximum value is 1099.3. If you want to see where the value is maximum and where it is minimum, you can click over here in the probe option. Here you can see it is maximum. You can just tilt the body. You can see it is maximum 1099.3 watt per meter square. And here it is minimum, which is 968.54 watt per meter square. So this gives you the result for stainless steel. Suppose if I want to see the result for CPVC, I'll go to solid again, change the material to CPVC, go to solution and solve once again. First we'll go to temperature. Now you can click on max min and remove these tags. So now you can see the inner temperature is 45 and the outer one is 35.204 degrees Celsius. So there is a variation of temperature as compared to stainless steel. Then we'll go for total heat flux. You can see here the maximum value is 565.82. Now you can click on max min. So here you can see this is the maximum inside, and on the outside it is minimum 508.95 watt per meter square. And if you want to see the temperature too, which is on this face, this variation is clearly visible. You can remove max min and you can just see this result over here. So this is again giving you a variation of temperature on this edge. This is about the thickness of the pipe. So these are the results obtained on this pipe. So with this, I end the session. I hope you have understood the thermal analysis of a 45-degree bent pipe. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.